Andy, I wanted to ask you about, so we've put in the contact gaps in the ANSYS model, and as a stress analyst and as an aerospace engineer, when you look at that, how do you interpret it?
Let me go to the video. Let me go to the actual model,
Hmm.
and then I'll show you how I take a look at this. So in terms of gapping, there's a great tool under contacts that provides the gapping at the different time steps.
And we already
And
added that in the model.
yes,
So students can, have that result, and, we want your insights on how do you kind of interpret those results.
so I'm gonna invert the scale here. Typically, red I like to be bad, and then blue to be good. So I'm going to do the invert scale. Let me just remember how to do this. Okay, reverse rainbow. Okay, great. So blue would be in compression here, and then red would be gapping. Looks like there's an area of gapping over here. I don't quite believe that. It could just be a figment of the model or something minor. Much more interested in what the gapping looks like along this boundary over here. So I'm going to probe it, and this is pretty much zero. There isn't much gapping there. That's because this is the preload step. So we wouldn't really expect any gapping. There's no outside forces that are trying to pry this thing apart. So more interesting is the second step. So let me change the reverse rainbow. You don't have to do this, students. I do this because that's what I'm used to. Now, the gapping over here is approximately 0.005 inches, which is what we call 5 thousandths of an inch. This gapping over here, not too worried about. I'm more worried about the sealing agent. So that could be a metal ring, or that could be an elastomer extruding through this hole. So typically, I've seen allowables of between 5 thousandths and 10 thousandths of an inch, or 0.005 to 0.01 inches in the specifications I've seen online. So this is kind of on the verge. Ideally, we would want this lower, but this is what we have. Now, the gapping is effectively zero as we move away from this due to the clamping that we have. And then finally, we have this last location, and the gapping is pretty much the same as the last step. So the thermal didn't really affect it as much. Now, we would see an impact from thermal if the coefficient of thermal expansion was very different between the bolt and the actual flange material. For example, if when this got hot, if the bolt grew more than the flange, we would expect greater gapping because we would lose some of the preload effect. So these are the kinds of things that are nice about these simulation packages. You get these second order, third order effects that you can capture in the software. It is it is difficult to predict gapping using hand calculations. So what I do is I validate as much as I can about hoop stress and the thermal strain or the thermal growth and other areas to make sure that effects like these, which are harder to capture, are likely correct. Um, and the one more thing that I'll do is I'm going to exaggerate this so I can more clearly see it, and so we can see what the actual visual is. So this is the visual. If I wanted to double check this, I could actually compare this deformation with the scale at the bottom of the screen and make sure that corresponds to how I deform this. But I can also see whether the bolt is in severe bending. I can make sure that this stays in compression. But no, this actually looks reasonable. So in operation, I would not expect this to really leak.
Okay. And if you wanted to, it seemed like you were right at the edge, and if you wanted to make that, the gapping to be even smaller after the second load step, what would be the design
Oh,
kind of
yeah.
changes that you would consider?
You read my mind. It's like the perfect question.
Because that's, I
So
think, the great thing about simulation, right? You can do these what if scenarios, which are very
I
difficult to
love
do in
it. It's
practice.
like you can do 100 experiments all at once on your computer, and it saves so much time. It's amazing. It's like all these experiments that you can do right at once. And when you get really good at ANSYS, there are ways to automate the experiments, and you can come back to your desk the next morning, and then it tells you, okay, this is what I found in these different scenarios, and it can come up with an optimum for you. It's really actually pretty neat. Okay, so to me, the interesting part is, okay, well, what's next? What can one do to decrease the gapping? So one can increase the preload between the bolt and nut. One can put in washers or a doubler between the bolt and then the flange. One could add in a larger radius where you see this flange. And actually, going back a step, going back to the original pictures that these models were based off of. I didn't have a schematic to work off of, so I built based on those. If one did more research, they may actually find that the geometry is different. Perhaps this flange is actually 50% thicker. In which case this gapping would go down. And then I would also say that in addition to playing with geometry and the preloads, what about the uncertainty? You may be thinking that, oh, what about this regen pressure that I put in here? I essentially approximated that. And if this was off by a factor of 2, then how does that affect the results? So and it makes it pretty interesting. I did that yesterday night, and I found that if I double the regen pressure, the gapping approximately doubles or triples. So knowing that parameter has a strong effect is also really important. So what I like about this problem is that it's kind of like a fuzzy problem where not everything's given to you. But you still need an answer because you have a grade depending on it. or for me, if I was doing research on how the Saturn V designed their nozzle so I could design my nozzle, then I need a result quickly. So I'm going to have to make approximations, but I also need to know, okay, well, I made approximations here. I could be off here. That's something to look at in the future.
Yeah.
Yeah.
And which of these inputs it's very sensitive to, and which of them it's relatively insensitive
Yes.
to.
Definitely.
Yeah. Okay. Great insights. Thank you, Andy.